Hi, welcome to Lecture 2 of Vector101. What you're watching right now is in fact not a recording of the original lecture, but a re-recording because we had some technical difficulties with recording and with internet. But the content, the content will still be the same. So partway through you'll notice the video will change, the vocal quality will change, but it is still true to the original experience. Okay, let's get started. So first I want to talk about who I am. My name is Ethan. I go by Astrocode on Roblox. I've been on Roblox since 2009, and Roblox is how I got my start doing math. I wanted to make games, and I realized that to make games you have to know some math, and this started a journey for me where I realized that I wanted to do more math, pursue a degree in it, and so I will be graduating with my undergrad in the fall. And then as far as Roblox goes, maybe you know my work from this cockroach game that I made. Yeah. Okay, so then why am I helping with this course? Well, for one, I want to raise the mathematical understanding of the Roblox developer community. Because by doing math, by doing any kind of math, turns out you get better at all kinds of math. And I mean, Roblox and math, these are my two favorite things, and so I want to combine the two and help out with Roblox from what I've learned doing math. Okay, and then second, while we're here, I might as well teach something that's directly applicable to game development. Linear algebra is very applicable. And then lastly, I want to improve my own teaching because I enjoy teaching math. All right, just some reminders. So with this course, you get out what you put in, because nobody is forcing you to be here. There is no college credit. We are providing this for free because we want to help people. And the way that you can maximize your time here doing this course is to, one, take notes during lecture or the recording, and to do the exercises. And this one is really important because math does not happen. You do not learn math from lecture. You learn math from doing the exercises and thinking really hard. So really do the exercises. And then my final reminder is that office hours are on Saturdays at 1 p.m. Pacific time. That'll be every Saturday for the next 10 weeks. And in fact, even before the course, we've hosted office hours. So come say hi to us. All right. I'm going to start out by recapping a little bit of what we talked about on Monday. And we started out talking about lists and sets. And I claim that you already know what these are because we talk about lists and sets all the time in programming. So a list just stores ordered data. And we denote lists with parentheses, 1, 2, 3. And when I say ordered, what I mean is that this is not the same thing as 3, 2, 1. They are in a different order. Whereas sets store unordered data. So for sets, we denote them with these curly brackets. And because it is unordered, this is the same thing as 3, 2, 1. It's the same thing as 2, 3, 1. It's the same thing as 1, 2, 2, 3. Because with sets, we don't care about duplicates. Okay, and then our favorite set is a set of real numbers, which we denote by this funky R symbol. And this may look familiar because the logo for the Robloxian Mathematical Society is based on this. Okay. Now the real numbers, we've usually seen it drawn as a number line. So in the number line, we have all of our favorites like 0, 1, and 2, and we have the negative integers. We have we got pi here, we have e here, maybe all the way over there is 10 to the 100. So almost probably every number that you've ever worked with is in this set, is in the real numbers. So the real numbers is a really big set. It is an infinite set, and it is what we call one-dimensional Euclidean space. And then we can go into higher dimensions. So R2, you've probably seen drawn before with X and Y axes. And so this whole thing is R2. It is the set of all lists of two real numbers. So for example, a point in R2 would be like 1, 2, and this is a list with two real numbers. Okay, and then R3, we can keep going. So we can have X, Y, and Z axes, and all of this is R3, and then keep going again. So Rn, when we don't care exactly which dimension we're in, we just say Rn. And so when we develop the theory of linear algebra of like vectors and matrices, we want to develop this theory in any dimension. And so most often we're just going to be working in Rn. And Rn, this is the set of all lists of n real numbers.
Next, let's talk about what is inside of the Euclidean space, which is vectors. And on Roblox, we have a particular way of using vectors, which is, to us, vectors are these physical quantities. So we use vectors for position, velocity, acceleration, force, torque, all of these sorts of things. And so what they all have in common is that they all have magnitude, and they all have direction. What do I mean by this? So I'm going to draw an arrow, and this could represent like the velocity of an object or something. Okay, and so this arrow, it has a magnitude in the sense that it has a length, so this is its magnitude. And then its direction is that it's pointing that way. Okay, and so I claim that, at least in Roblox, a vector is fundamentally just an arrow. Because of this, what we just saw, that it has a magnitude, it has direction, like this is precisely what we care about. And I mean, you will, if you take more linear algebra, you will start to call some funny things vectors. It's a little strange, but really a vector is just an arrow. I mean, it depends on your use case. So on Monday, we talked about how you could represent bank accounts, 1 million bank accounts, in a 1,000,000 dimensional vector. Okay, in that case, it doesn't really make sense to talk about like what is the magnitude and direction of your bank account. It's kind of a silly thing. Okay, but at least in Roblox, a vector is just an arrow. Okay, and so we're going to reinterpret some of the things that we talked about on Monday in terms of arrows. Okay, so on Monday we talked about one operation we can do with vectors, which is scalar multiplication. That given alpha in the real numbers and some vector, we can multiply alpha and the vector, and the way that we multiply them is we multiply each component. So we take x1 and we multiply it by alpha. We take x2 and we multiply by alpha, and so on. Walk through an example. So if alpha is -3 and x is 2, -1, can somebody tell me what alpha x is? Yep, that's right. -6, 3. Okay, and so let's draw out x. So x is 2, -1. So there's x. And then alpha x is -6, 3. So that's going to be out there. Let me actually do that in a different color. This is alpha x. This is alpha. Okay, and they're supposed to be like along the same line. And so the result of this is two things. One, we scaled the magnitude. So we started with a vector this long, and we got a vector this long. And then two, we also got a vector in the different direction. Okay, so this is what scalar multiplication does graphically, is it scales our arrow, and it can reverse the direction of our arrow. All right, now let's talk about vector addition. So if we have two vectors x, y, the way that we sum them is we sum each individual component. So we take x1, y1, and we sum them. We take x2, y2, and we sum them, and so on. And so let's walk through an example of what this looks like graphically. All right, so we take x, we add that to y, so it's going to be negative 2 plus 4. That'll be 2. 5 plus negative 1, this will be 4. All right, and so what do these vectors look like? Let's start by drawing x. So x is negative 2, 5. Something like that. And then y is 4, negative 1. 1, 2, 3, 4. Negative 1. Okay. And then x plus y is going to be 2, 4. So this is 1, 2. There. All right. So how do we understand this graphically? Well, I'll show you. So we're going to label these. We're going to take this vector and we just stick it on the end of x. Okay, what's supposed to happen is that these two are supposed to line up. Okay, and so what we did is we stacked one vector onto the other, and we got our result, which is x plus y. And what's neat is that we can do this in the reverse way too, so that we can also take x, and we stack it onto y, and this is supposed to give the same thing. Okay, so whether you do x plus y or y plus x doesn't matter, it's the same thing. And the way that we add vectors is we add them tip to tail. This is how vector addition looks. Are there any questions so far? Okay. On Monday, we also talked about how to take the product of two vectors. And what's important here is that there is no natural predefined way of multiplying vectors. There are many different ways to multiply vectors, well, in a way that acts product-like. Okay, so some that we know really well are the scalar product, the dot product, the inner product. These are all the same name. They're all different names for the same thing. And Roblox, this is x dot y. We also love the cross product or the vector product. I wouldn't worry about this formula here. In fact, it will never come up in the future, but you actually might want to reference this for your homework. Okay. And then lastly, in Roblox, you can also do the Hadamard product. Okay, and so in a few minutes, we're actually going to code some of these. Okay, so to summarize, vectors that represent physical quantities and the way that we use them in Roblox are fundamentally just arrows. And when we do scalar multiplication, two things can happen. We can scale the magnitude, and we can reverse direction. And then lastly, when we add vectors graphically, it is performed tip to tail. Okay, so hopefully when you work with vector 2s and vector 3s in Roblox, you can now draw them out with arrows and you can understand what is happening. All right, now is where reality strikes, because we love drawing arrows. We understand arrows. At the end of the day, if we want to do computations with vectors, then we have to use coordinates. Okay, and so that's what we're going to do now is we're going to code a general vector object. So instead of a vector 2 or vector 3, we can give it any amount of elements that we want. So let me switch over to a text editor, and let me know if you have any questions. Okay, here we are in Sublime, and I have a few files open now. I know all of us are probably familiar and comfortable with Roblox, but because we'll be dealing with vectors in any dimension, it's kind of not useful to be in Roblox. So we're going to do it with just pure luau, And if you don't have Luau, you can install it from Roblox GitHub. There. That's the link if you don't have Luau. Okay, so let's talk about the goals for today. So what we want to do is we want to create a vector object, and we want to code the operations that it has, and then some of the special vector products. And then for homework, I'm going to have you do the cross product, and I think one other thing. Okay, so let's get started. So the first thing we're going to do is just create a vector class. And we're going to need a constructor for this. And our constructor is going to take in just a list of numbers. Okay, so fundamentally, a vector really is, at least in coordinates, is just a list. Okay, and we have a way to represent a list in Roblox. It's just a table. All right, but if we want to do something like this, so if we want to have two lists and then add them, okay, well, there's no predefined way to do this. Luau does not know how to add tables. We have to tell it how to add tables. Okay, and so what we're going to do is we're going to tack onto our coordinates. So let's be clear, our coordinates are a list of numbers. All right, and we're going to tack on to our coordinates a meta table. So if you've not seen meta tables, a meta table just adds some extra functionality onto a table. And in particular, what we're going to add on to start is addition. Okay, so how we're going to do this is we're going to define a function in our meta table called __add. And this is a special function that Lua takes and it knows now how to do addition. Okay, so we're going to take in two inputs and we're going to output the sum of two vectors. Okay, and what we have to make sure of is that we are in fact receiving these two vectors, okay, because this add operation, it will be called even if I try to add a vector with something that's not a vector. We need to make sure that both A and B are indeed vectors. And to do this, we're just going to do a basic is vector check. So this is going to take in an input, and we're just going to make sure that its meta table is indeed the meta table for a vector. Oops. Take an input, and we just make sure that the thing that we tacked onto it is indeed the correct meta table. Okay, and so what this allows us to do is we're going to assert that A is a vector, and we'll assert that B is a vector. And then what we also need to do is we need to make sure that the lengths of these vectors are the same, because you cannot add a vector, like in the same way that you can't add a vector 2 to a vector 3, the vectors have to have the same length. Okay, so we'll also assert that the length of A is the length of B. All right, and now we can finally implement addition. So we're going to create a new table for coordinates, and we're going to, for every coordinate, we just add up the ith coordinate of A and the ith coordinate of B. We're going to put it in our table and then return a new vector. All right, so let's now test this. Quires look a little bit different when you're not in Roblox. So we'll make a vector. All right, and then we will add it. And then my terminal. Okay. I forgot. The toString. Okay, so right now, when we just print a table, we were just seeing like the memory address of the table. Okay, and so we have to do something special here, which is tack on functionality for printing our vector nice and pretty. Okay, and so this is also another special meta method. It's called toString. We'll take in the vector, and what we'll return is something that's nicely formatted. So we'll concatenate all of the coordinates of the vector. Something like this. All right, let's run it again. All right, very good. So 2, 3, 4, 5, 6. Yeah, that looks right. Okay, good. So now we have vector addition. Vector subtraction is basically the same thing. So we'll do that now. So the meta method for this is sub. And we do the same thing, except we change our addition to subtraction. And let's look at that. All right. Check our to-do list. Okay, so we've created a vector object. We can check if something is a vector. We can do vector addition. We can do vector subtraction. All right, now let's do scalar multiplication. So again, we'll take in two things, but this time we need to make sure that one of them is a vector and one of them is a number. And so, for example, both a times 5 and 5 times a work. So we need to make sure, so we'll check either a is going to be a number and b is a vector. Or a is a vector and b is a number. And then lastly, if neither of these are the case, then we'll just yell at the user. All right. Okay, so now we can finally implement our multiplication. So we'll create some new coordinates, and then we're going to loop through every coordinate of b. And we'll multiply it by a. Okay, and then we'll return a new vector. And then similarly, we'll just copy and paste this, and we'll do it the same way for the other direction. Okay, let's run our test. Very good, we got the same result. All right, so there's scalar multiplication. Now we also need negation. This one's like a little funny. Because if you want to negate a vector, you could, well, no, okay. What we're trying to do is trying to do negative a. And there's a special meta method for this one too. Okay. So this time, we know that our input is going to be a vector. We don't have to do any checks, and all we're going to do is negate every coordinate. Okay, let's test that. All right, good. Next, we can move on to some of the more special things like the dot product, the pointwise product. Okay, now these ones are a little bit different. Now we can actually go back to our vector table. So if we want to do something like a dot b, we need to add, well, currently a is just a table with a meta table. It doesn't know what the dot function is, and the way we're going to tell it what the dot function is a little confusing. Okay, so maybe just watch and then I'll explain it. Okay, so what's happening here is that we want to call the dot function on a. Okay, but a is just a table. So then it goes to its meta table and it says, hey, meta table, do you have the dot function? It says, no, but I think I know who might have the dot function. It's vector. And then vector, yes, okay, good, we found the dot function. So there's kind of a little bit of indirection here. It's the unfortunate fact of using meta tables for object-oriented programming. Okay, but we'll now code our dot function. And again, we should make sure that A and B are vectors and that they have the same length. Okay, and now we're going to need to sum the product of each coordinate. Dot called with, sorry, I'm reading the chat. You can call a function with a method call. Call a function with a method call. Yeah, okay, so usually you've probably seen this written as vector colon dot. And then implicitly, what was just written as A is now self. It's just like a nice syntax, I guess. But we can instead make it explicit, and we can use a dot, and then have self as the first parameter. And so that's all I was doing is I wanted to call instead of self, I wanted to write A, and so I used a dot here. Yes, I'll post the code later. It'll probably be up on the RBX Math GitHub. And I'll post most of it. Some of it will be left for homework. And then in a week or so, I'll post all of it. Okay, so that resolves our syntax confusion. All right, now we'll finish up our dot product. And remember, the way that a dot product works is we sum the ith coordinate of A and B together. Or sorry, we take the product of AI and BI, and then we sum it all up. And we'll return the sum. Okay, so let's try out A dot B. That doesn't seem right. I didn't save it. Okay. So if you're ever curious what is happening under the hood with the dot product for choosing vector 3, this is what's happening. All right, and then the last thing that we'll do is we'll implement this Hadamard product here. And so this is what happens by default when you multiply two vectors in Roblox, when you do A times B. And now we've already programmed the functionality for multiplying by a scalar on the left and the right, and now we need to add a third option, which is for when we're multiplying two vectors. So if A is a vector and B is a vector, then we're going to do this Hadamard product. All right, and so once again, we're creating a new vector. We're going to loop through every index. And the ith coordinate is going to be AI times BI. And we're going to return a new vector. Let's see how that goes. Does that make sense? Okay. The example's a little silly. Let's try a bit of a harder example. I'll replace each of these with 2. Okay. 2, 4, 6, 8, 10, right? So 1 times 2, 2 times 2, 3 times 2, right? Okay, very good. So what do we have? So in just under 100 lines and 99 lines, we have our own vector class, and it can take in any amount of coordinates, and it can do vector addition, it can do scalar multiplication. We have dot product, we have a Hadamard product. Fantastic. Woohoo, let's go. Okay. Now, homework for you all. This will be, you should try to get this done before next class, next Thursday, is implement the cross product. And recall, I put the formula for the cross product in the notes. So cross product for vectors, for vectors in 3 dimensions. It is only defined on vectors in 3 dimensions. What else? I had a list somewhere. One of the things that was on the list was code it better than me. I know you all are very good programmers. I am not. I trust that you can do a better job of this. Okay, and then the last thing I was going to assign for homework is to do magnitude. And magnitude actually might not have ended up in the notes. It is in Aiden's notes, though. Okay, and I guess there's something a little bit tricky about magnitude. Okay, so the way that we use magnitude in Roblox is we would do it like just a dot magnitude, where magnitude is a property of a. It's like a little strange in metatable world to do this. So actually what I would just encourage you to do instead is just do magnitude as a method. Okay, so that concludes the programming for today. Because this was the first week, there really wasn't much to do. In the future, there will be a lot more. But I think that will do it for today. Thank you all for coming. And remember that office hours are on Saturday at 1 p.m. Pacific. I'll hang around for questions now.